Hello everyone, welcome to this video on perfect improvement and substation engineering. This is video number 2 of unit 6. Let us in this video we shall learn the learning outcome number 2, that is disadvantages of low power factor. So low power factor can lead to several negative consequences for both power system and the consumer. So what are the disadvantages? The first one is increased current. To deliver the same amount of real power, higher current is required, leading to increased losses in the system. So how you say that if the power factor PF, if it is decreased, here it is said that the current is increased. So how it is? Let us find out from our equation for P. P is equal to VI cos phi, where this is our power factor cos phi. So I can write I is equal to P divided by V cos phi. Now in this equation, if P is constant and V is constant, both are not varying. Only power factor of it is varying. Now you can see here, if the power factor is decreasing because of inductive load or capacitive load, then the current will found to be increased. So suppose if I have a transmission line, say, and I have a load, and this load, if power factor of this load, if it is decreasing, then the current in this line, it will increase. And what is the problem with this increasing current? So we can see that there will be higher copper losses. If the current is increasing, then obviously your I square R loss. So whatever loss is happening here in this conductor, that is I square R loss, will increase in the conductor, even in the transformers. So wherever that current will flow, that we will have higher copper loss. And what happens to the if it is increasing current? Increase in current can overload electrical equipments. So if you have a transformer, or if you have or your transmission line, then the capacity of the it may happen that the transformer may be overloaded or the transmission line may be overloaded. So it will reduce the system capacity. Okay. Next, poor voltage regulation. So what is voltage regulation? You can see the voltage regulation means what? Suppose uh, if this is your sending in voltage of the transmission line, and here it is the receiving end voltage line, and the voltage drop, voltage drop, you can say it is Vs minus Vr. So now this voltage drop, Vs minus Vr voltage drop, it will increase if the power factor is decrease. How it is? Because if the power factor is decreased, the current is increased. If the current is increased, then the voltage drop IR will increase. So whatever voltage drop here, it will increase and it will reduce the transmission voltage. So whatever receiving voltage we get, it will not be to the standard value. It will be reduced value. Then increase energy lost. As we have seen, if the current is increasing, obviously there will be more loss in the transmission line, and that will cause your the energy consumption, it will increase, and obviously the cost of the energy will increase. Then reduce efficiency because of increased losses into the system, whether it is transmission line or transformer, then obviously your efficiency will also decrease. Large equipment ratings. For supplying low power factor loads, you have to give more current, and if you want to give more current, you should have a larger capacity of transformer, transmission line, or generator, or in the protection devices. So it will increase the cost of the system. Okay, so this is another question that is important in this unit 6, that is disadvantages of low power factor. So you can explain this in your university question paper. So in this video, up to this only, we will continue in the next video. Thank you very much.